An automated trading bot is, well, a computer program. It's designed to execute trades on financial markets without direct human intervention. These bots follow a predefined set of rules or sometimes really complex algorithms to make decisions. The primary goal here is to remove the emotional element from trading. Humans can often make poor choices based on fear or greed. A bot, however, will stick to its strategy. It operates based on logic and data alone. This disciplined approach can lead to more consistent results over the long term. Actually, many professional trading firms rely heavily on such automated systems to manage their portfolios and execute trades at high speeds, something a human trader simply cannot match. But the reason for using a trading bot extends beyond just emotional discipline. These systems can monitor markets 24 hours a day, 7 days a week. That's just impossible for a human. They can analyze vast amounts of historical and real-time data in seconds. A bot can spot potential trading opportunities that a person might easily miss. Furthermore, they can execute trades almost instantly. This speed is crucial in volatile markets where prices can change in a fraction of a second. By automating the process, traders can free up their time to focus on developing and refining their strategies, rather than being glued to a screen watching price charts all day long. For individuals new to this field, the idea of building a trading bot might seem intimidating. However, with modern tools, it's become more accessible than ever before. You don't need to be a Wall Street expert to get started. The core concept is simple. You create a program that analyzes data, makes a prediction about future price movement, and then acts on that prediction. For example, if the bot predicts a stock price will go up, it might issue a command to buy that stock. If it predicts the price will fall, it might issue a command to sell. This essay will guide you through the basic steps to build your very own simple trading bot. Our approach will be straightforward and focused on learning the fundamentals. We won't be creating a system that will generate immense profits overnight because honestly that's just not realistic. Instead, we'll build a foundation of knowledge. You'll learn how to use powerful programming tools to interact with financial data and make intelligent, data-driven decisions. The aim is to understand the process from start to finish. This will give you the confidence and the skills needed to explore more complex strategies later on. We'll demystify the world of algorithmic trading and show you that it's a field you can participate in. To begin our journey, we need to assemble the right set of tools. The primary tool we'll use is the Python programming language. Python is incredibly popular in the world of data science and finance, and for good reason. It has a simple, readable syntax which makes it an excellent choice for beginners. More importantly, it's supported by a massive community and has a rich ecosystem of libraries specifically designed for data analysis, machine learning, and financial modeling. You can think of Python as the foundation upon which we'll build our entire trading system. It's the language we'll use to write all of our instructions for the bot to follow. The second critical tool is TensorFlow. This is an open-source library developed by Google for machine learning and artificial intelligence. We'll use TensorFlow to create the brain of our trading bot. Its job will be to learn from historical stock price data and make predictions about future prices. TensorFlow really simplifies the process of building complex mathematical models, known as neural networks. These networks are inspired by the human brain and are exceptionally good at finding patterns in data. By feeding it past stock prices, we can train a model to forecast what the price might do next, which is the core of our trading strategy. With our tools selected, the next step is to acquire the necessary data. A trading bot is only as good as the data it's trained on. We need historical financial data for the asset we want to trade, such as a particular stock. For our example, let's say we want to trade Apple Inc. or AAPL stock. We'll need its daily opening price, closing price, highest price, and lowest price for the last several years. Fortunately, there are many sources for this information. Several free online APIs like those from Yahoo Finance or AlphaVantage allow you to download this historical data directly into your Python program with just a few lines of code. The process of getting this data is quite simple. You'll typically use a Python library such as YFinance or Pandas Data Reader to connect to the data provider's service. You specify the stock ticker, for example AAPL, and the date range you're interested in. The library then sends a request to the service and receives the historical data, which is usually organized into a clean table-like format called a data frame. This data frame will contain columns for the date, open, high, low, and close prices. This structured data is the raw material we'll feed into our TensorFlow model to teach it about the stock's past behavior. Now that we have our historical stock data, we can start building the predictive model using TensorFlow. The goal is to train a model that can look at a sequence of past prices and predict the next day's closing price. We'll use a type of neural network called a long short-term memory, or LSTM network. LSTMs are particularly well suited for this task because they're designed to recognize patterns in sequences of data like a time series of stock prices. They have a form of memory that allows them to remember important information from earlier in the sequence, which can be crucial for making accurate future predictions. The first step in the training process is to prepare our data. We can't just feed the raw price data directly into the model. We need to normalize it, which typically means scaling all the price values to a range between 0 and 1. This helps the neural network learn more efficiently. Next, we must create training examples from our historical data. For instance, we could take a sequence of 60 consecutive days of closing prices as our input, the features, and use the closing price of the 61st day as the output, the label. We slide this 61-day window across our entire data set to generate hundreds or thousands of these training examples. Once our data is prepared, we feed it into the LSTM model. The training process is kind of like teaching a student. We show the model an input sequence, 60 days of prices, and ask it to predict the output, which is the 61st day's price. Initially, its predictions will be random and pretty inaccurate. We then compare the model's prediction to the actual price. The difference between the two is called the error. We use this error to slightly adjust the internal connections of the neural network. This adjustment process is done automatically by TensorFlow's algorithms. The goal is to minimize the error over time, making the model's predictions progressively better. We repeat this process of showing the model data, getting a prediction, calculating the error, and adjusting the model for many cycles, which are known as epochs. With each epoch, the model learns the underlying patterns in the stock's price movements more effectively. After the training is complete, we'll have a model that has learned the historical behavior of the stock. We can then give it the most recent 60 days of price data it has never seen before, and it will generate a prediction for what the closing price will be on the next trading day. This predicted price is the crucial piece of information our bot will use to make a trading decision. With a trained model that can predict the next day's stock price, we can now build the logic for our trading bot. This is where we translate the model's output into a concrete action to buy, sell, or hold. The simplest strategy is a directional one. We compare the predicted price for tomorrow with the most recent known closing price. If our model predicts that tomorrow's closing price will be higher than today's closing price, it's a signal to buy the stock. The logic is that we expect the price to rise, so we want to own the asset to profit from that increase. Conversely, if the model predicts that tomorrow's closing price will be lower than today's closing price, it's a signal to sell. If we already own the stock, we'd sell it to avoid a potential loss. If we don't own it, our simple bot might just decide to do nothing or hold. This decision-making process is coded directly into our Python script. The script will fetch the latest data, feed it to the trained TensorFlow model, get the prediction, and then execute the buy or sell logic based on this simple comparison. This forms a complete, albeit basic, automated trading cycle. It is critically important to start with caution. Before letting your bot trade with real money, you must test it thoroughly. This is done through a process called backtesting, where you simulate your bot's strategy on historical data to see how it would have performed in the past. You can run your buy or sell logic over several years of data and calculate the hypothetical profit or loss. This helps you understand the strengths and weaknesses of your strategy. Following backtesting, you should engage in paper trading, which involves running your bot in real time, but with a simulated account and fake money. This allows you to see how it performs in live market conditions without any financial risk. Finally, remember that building a trading bot is a continuous process of improvement. A simple model that only looks at closing prices is just a starting point. You can enhance your bot by feeding it more data, such as trading volume or news sentiment. You could also explore more sophisticated machine learning models or develop more complex trading rules. For example, instead of just buying or selling, you could implement stop-loss orders to limit potential losses. Always be responsible. Never risk more money than you're willing to lose, and understand that no model can predict the future with perfect accuracy. The goal is to build a system that gives you a statistical edge over the long run.